All right. So this week we are on chapter 11. There's 4 more weeks to go. This chapter really focuses on kind of research that's aimed at studying causality, but is not true experiments. So it's kind of like doing the best you can if you can't do a true experiment. In terms of what's coming up, so this Sunday, there's the quiz 5 and SmartBook chapter 11. This is really all that's left in the class. So essentially, yeah, including this week, there'll be 4 more SmartBook chapters, 2 more quizzes. There's the second exam, and then there's the 4th writing assignment. I know you just completed the 3rd writing assignment, so probably not wanting to get started on that right away, but I did post it to Blackboard so you can see what's going to be involved, and I can just briefly sort of talk through it right now. So I guess one thing to note real quick is that the syllabus had this due like 2 weeks earlier. So I pushed it back by 2 weeks so that it'll kind of be the last thing that you do in this class, and it'll be due like a full week after the second exam is due. So you'll have like kind of the whole finals week to work on it. And it's kind of similar in terms of what's going to be required of you as to the 3rd writing assignment. It's worth the same amount of points, 150 points, but this is like, it's less structured. So the 3rd writing assignment had like specific questions and you're answering them throughout. This is more you coming up with your own research proposal, and it does have sections. So it should have a title page, an abstract. An abstract is just like this sort of summary at what would be on the 2nd page. Then you have an introduction. So this is where we're getting to kind of the components of your research proposal. So introducing your research topic, that includes a literature review and hypotheses or research questions. Then you'll have a method section. You're not actually going to do this research, so it's going to be like a hypothetical method section. You will be kind of asked to talk a little bit about the results in the discussion in terms of like what results would you find if your hypothesis was supported or not. But again, you don't have to go out and do this study, and then you need to include finally references. So it's kind of like we did last week, the activity where you had to come up with like different ways of testing a research question. That was similar to what you'll be doing here. And you can, if you like the topic that you came up with last week, you can just use that. But I guess some other things to note, you have to include at least 5 references. So that means that you have to go, maybe next week I'll talk about kind of how to go find references, but you just go on Google Scholar or the UH Library website, and you can look up searches related to your proposal. Google Scholar is probably the easiest, but sometimes it's hard to it can be hard to download the actual articles from Google Scholar. So that's where the UH library comes in, because the University of Houston is paying for access to all these journals. So you might as well use that. Basically, yeah, so you're not going to be collecting data, but in the discussion, we'll talk about what, if your hypothesis was supported, like what the results would look like, and what would happen if your hypothesis was not supported. The overall length is going to be 5 to 7 pages of text. So that does not include the title page, abstract, and references. So including these sections, it'll probably be at least like 9 pages, I guess, or 8 pages at a minimum. Just general tips. I think in terms of like the research question that you come up with, just it's best to have something that's relatively straightforward. And by that, I just mean like, don't propose a bunch of like confusing interactions. Like just keep a single research question, like we talked about last week, where it could be like sort of how strongly does one sort of independent variable predict a dependent variable, something like that. You can write it in terms of the future tense, like I'm going to do this, but it doesn't really matter. The tense doesn't matter. Just be consistent. And then on this page is the grading criteria. So you can see how the 150 points are going to be distributed across the different sections. So this is really important to go through. So this is what we're going to use to grade it. So basically, like, you have the key here. So just make sure that each aspect of this grading rubric is reflected also in your paper. So in your introduction, for example, this is what you need to do. Basically introduce the problem or research domain, introduce a specific research question, a literature review. So you have to kind of go in and find other studies on that topic. Pretty much any sort of topic that you come up with, there's probably some related research on it. It doesn't have to be the exact topic of your study, but something related. And then, yeah, providing details about your study and why it's important, and then presenting some hypotheses. So I'm not going to talk through every exact thing in this rubric, except just to say that, yeah, like, go through the rubric. And then the only other thing I will just show you kind of real quickly is on Blackboard, there's 2 sample papers that were completed for different sections of this course in previous semesters. But it gives you just a sense of like kind of what the end product is going to look like. So this is your title page. This is the page. Page 2 will have the abstract on it. And then here's the introduction. Then there's a method section. And then a discussion. And then at the end, there'll be references. Are there any questions about this? I apologize if you can hear my dog eating in the background. She likes to wait right till class is about to start before she will eat her breakfast. So no questions about writing assignment 4? Like I said, I know you just finished writing assignment 3, so probably not super enthusiastic to get started on it right away, but you don't have to anyway. You have over a month. And we can talk through maybe parts of it in future weeks too. And if you have questions, once you kind of get into it, yeah, just email me or bring them up at the beginning of class. Okay, so in this chapter, as I kind of mentioned in the title slide, like we're focusing now on research designs apart from true experiments that are aimed at studying cause and effect. So that includes what are called single case experimental designs, where you just have only one participant. Research designs where you don't have a control group, so there's only one group. These are methods of similar sort of thing, like one group designs where you study something over time. And then we'll talk about like developmental research designs where you're primarily interested in studying kind of like the effects of aging, and there's different ways of doing that. Before we do that, let's do a poll. These are questions, by the way, at least the first 2 are from last week, or topics that we covered last week. All right, 30 more seconds. Still waiting on 7 people. 5 people. 3 people. 2. 10 more seconds. All right. So let's go through these results real quick. The first question was kind of like an applied question of, again, things we talked about last week, but the correct answer here is an interaction effect. So remember, we talked about basically how like you can set up studies where you have 2 independent variables, and sometimes you would do so to see basically whether or not one independent variable predicts a dependent variable differently depending on another independent variable. And so this example didn't use any of those words, but that's really kind of what's going on. And it is actually a finding that we talk about a lot in my area of psychology, that we're interested often in predicting job performance. And one sort of thing you can use to predict job performance is a test of cognitive ability. And so cognitive ability does predict job performance pretty much in all jobs, but it's a stronger predictor in more complex jobs. So the complexity of jobs is like the other independent variable here. And it's an interaction effect because the relationship between cognitive ability and job performance depends on job complexity. A main effect would just be like you could have the main effect of job complexity on job performance, or the main effect of cognitive ability on job performance. That would only be kind of one variable at a time on that dependent variable, which in this case is, again, job performance. So that's an interaction effect. And again, that was just like a real world example of one. How many levels of it? So we're kind of intermixing things that we talked about last week. How many levels of an independent variable are needed to detect a nonlinear effect? So if we talked about having also last week, having more than 2 levels of an independent variable, and essentially you need at least 3 to detect a nonlinear effect. And you can just think about it like, if you only have 2 levels of something and you think about a graph and you're trying to graph the relation, like no matter wherever you have 2 dots, you can only connect them with a straight line. So you need a 3rd dot in order for that to be non-linear. A true experiment uses a control group with random assignment. So that's what we're going to kind of talk about today, that like we'll talk about some designs that uses a non-equivalent control group, or some that don't have a control group. So again, that's the focus of this chapter. And it looks like it didn't go bad for anyone, so that's good. I know it was kind of a little bit more challenging than the previous 2, but looks like it went well for a lot of people, and at least okay for everyone else. So that's good. Are there any questions about anything before we move on? Okay, so the first research design that we're going to talk about today is called single case experimental designs. Again, like think about everything that we're talking about in this chapter is like you can't do a true experiment, but you're going to still trying to see if something causes something else. And so you do the best you can with what you have to work with. And so in some cases, it might be the case that like you only can get data on one participant. And you still want to see like if, so for example, let's say you're designing some sort of like exercise treatment that you think is better than normal exercise for helping people sleep at night. So you want to kind of see if this exercise intervention works, but you only have one participant available to you. So you have to kind of do your best that you can to see if this person who's going through this exercise treatment does actually get better sleep as a result of it. And so the main sort of thing that you would do in a single case experimental design, so because now you only have one person to look at, so you can't compare that person to other people. So you have to kind of compare that person to themselves over time. So what you would do basically is you have a baseline period that's before any sort of experimental manipulation. So you would essentially, if you're focusing on sleep as the outcome, and again, the intervention here is this exercise training program, you would measure people's sleep during a baseline period before they went through any sort of manipulation. Then you would measure it again during the manipulation and then afterwards as well. The main sort of challenge with this research design, again, we only have one person and we can't really generalize too much from one person. And also there could be just a lot of other things in that person's life that, so say they do get better sleep kind of for a few nights after the intervention starts. But how do we know that like there isn't something else in their life? Like maybe they're under less stress at work that week coincidentally. And so what we kind of are trying to do is rule out that these other potential causes were the source of their improvements in sleep apart from the actual exercise manipulation. So one sort of thing that we could do to have a little bit more certainty about cause and effect with a single case research design is what's called a reversal design. So essentially what we would do is a reversal design is a single case study where we would introduce the treatment, which again is this exercise intervention. And then we would take it away, and then we'd have another baseline period where we would still be focusing on like how does the person's sleep do, but now the intervention's gone. So that's the sort of reversal element of it. We introduce the intervention, then we take it away. So we have two baseline periods. So this is sometimes called an ABA design, and it's basically kind of the A's in this acronym stand for like the baseline periods, even though it's a little confusing because baseline starts with B, but just think about it like ABA, like we're in terms of the alphabet, like we're going forward, then we're going backwards. So in this reversal design, kind of like I just said, basically we would be, if sleep is the outcome that we're focused on, we'd be measuring sleep during the baseline control period. So if that person before they took the exercise intervention, we're measuring it while they're doing this exercise intervention, seeing if they get better sleep. And then again, during the second baseline period, after we've taken away that intervention to see if essentially if their sleep gets worse again, now that they're no longer doing the exercise. So one sort of really important point here is that this sort of design where you're taking away an intervention and seeing how like the second baseline period, how it looks in the second baseline period, it only works if you have an intervention that has temporary effects. So I think it could certainly, like exercise has somewhat lasting effects on the body, but they don't last for more than like a few weeks or a few months kind of at most. And so that could work for some sort of exercise. It could work for a lot of types of sort of therapy or behavioral interventions, or even kind of, I would say, most types of drug treatments that don't have permanent effects on the body. So you could see again, like if the person stopped taking a drug, their symptoms return. However, it would not work well for again, anything so it has like a lasting effect. So a surgery, for example, you can't, I mean, I suppose you could reverse a surgery, but that would be, you wouldn't want to do that. It would be unethical. So in a lot of surgeries, yeah, you can't really reverse. So that's the sort of core idea in terms of an ABA reversal design. Just to kind of illustrate it a little bit more too. So this is an example from the book where we could think about it like kind of here, it's some sort of like behavioral intervention around homework where let's say researchers designed like an intervention to help students, or in this case, one student, like focus on their homework more. So when this is the baseline period, again, before the intervention was introduced, and you can see that this particular person is really struggling with homework. They're only getting 0 or 1 homework problem correct. Then the treatment happens and they start doing much better on their homework. And then after the treatment's taken away, there's the second baseline period, and you can see that they kind of, maybe the treatment has a little bit of a lasting effect for 1 day, but then it goes right back down to the baseline. So this would be data that is fairly convincing that the treatment does in fact work, even though we have only one participant, just because we see this super clear pattern of improvement during the treatment and then the opposite of improvement, so getting worse again during the second baseline. So something that is often done if you only have one person to work with, you could at least kind of do it, well, in this case, you'd have like 3 people to work with. So like a replication of a single case design. So still kind of would be considered a single case design because you're still focusing on like each person individually, but it's still better if you could have 3 people go through this exercise program. In this case, again, you don't have a control group because all 3 people are going through the intervention program. And ultimately, like in order to do research where you have like groups of people that you're comparing, you need to have at least like 10 people in each group. Otherwise, you would just not have enough statistical power to detect any significant results. So anyway, yeah, this would involve, yeah, replicating the same procedure, going through, it could be participant B and C after participant A went through it. And in this sort of research, like you would, in terms of writing a paper about it, you would typically sort of focus on each participant individually and highlight maybe how participant A did during the treatment, how if participant B did differently at all, or if participant C did differently at all. So again, it's all kind of, it's still single case research. It's just like we're replicating it now across 3 people. And if we do have 3 people, more participants is always better. And so we can kind of make better inferences about whether or not the intervention is actually working. We could also design something that's called a multiple baseline design. So now we're kind of playing around with sort of the time interval or varying other things. Like we could vary the settings or sort of the types of behaviors that people were asked to do during the exercise program, things like that. And we really just want to see that kind of regardless of what we sort of tweak in this sort of multiple baseline design, we still see an effective treatment after the manipulation is introduced. And now we're introducing that manipulation sort of at different times for each individual. And if we do see that, like regardless of when we introduce the intervention, but it still seems to have an effect on each participant, that's a really good sign that like it is working, and it would help us rule out the possibility that other events were responsible. So let's just think that we have designed, we're researchers who designed an app to help people quit smoking, and we want to see if it works. But for now, we only have access to 3 participants who are willing to go through this sort of app. And so one thing that we might kind of worry about is that maybe there's some sort of thing going on in society, or just something that's happening at the same time for each participant that could sort of be related to their smoking behaviors. And so we could introduce essentially the quit smoking app at 3 different time periods with different length baselines to see if regardless of, again, when we introduce it, does it still reduce people's smoking? So that sort of a design would look something like this. So this is, again, a multiple baseline design. We're still kind of in the single case experimental design research where we're focusing on sort of 1 person each time, even though in this case we have 3 people, but again, we're looking at the effects within each person across time. So what we see here is like there's different length baselines for each participant. So this first participant got the treatment introduced first, so they had a shorter baseline, and these are the number of weeks, and then the y-axis here is the number of cigarettes each person smoked per week. So roughly they all smoked about kind of close to 300 anyway before the treatment was introduced. And you can see for each person, once the treatment is introduced, they start smoking a lot less cigarettes. So again, that would be a really good sign that this intervention is working. There can always be some variability. I mean, this person, like you can see, kind of is going back up a little bit at week 12, but it's still kind of a marked reduction from their intervention baseline number of cigarettes. So basically that's gonna conclude anyway the single case research designs that we're covering in this chapter. Another common design, or something that often happens when you're trying to see if like some intervention has an effect on people, is that you can't find a control group for some reason. It is often hard to find control groups. It costs money typically to collect data on more people, and so if you can't find a good control group, then sometimes you're left with only kind of seeing how an intervention works within only one group of people. So pretty much everything that we're going to talk about from now until when we take the break, which is will be about 15 minutes probably, is going to be quasi-experimental designs. So the key sort of thing that defines a quasi-experiment and makes it different from a true experiment is that we don't have a real, like a true control group that we got through random assignment, but we're still going to kind of try to do the best we can to see if some sort of treatment had its intended effect. So there's different ways of setting it up that kind of vary from very bad to okay, I would say. This first one that we're going to cover, what's called a one group post-test only design. is a very bad design, generally speaking. So it's essentially in this sort of design, we only have one group of people and we don't have a pretest on those people, and all we can do is measure their behavior after the intervention occurred. So that's why it's called post-test only. So an example that they give in the book is, if you were interested in a research question could be whether or not, like, if I go and sit next to strangers in like a public place, do they get up quicker and move somewhere else? So if I was interested in doing this design and I went and sat next to strangers, so that's the independent variable here. The manipulation is me going and sitting next to a stranger. And then the outcome would be the amount of time until that person gets up and moves. So that's the dependent variable. So I could see, basically, I would have some measure here of how long people are taking to get up, but I have nothing to compare it to see whether or not they're getting up earlier than they would if I hadn't have sat next to them. So overall, this is a very bad design in terms of internal validity. Remember, internal validity has to do with whether or not we can make valid inferences about cause and effect in a study. And we don't have anything to compare, so we have an outcome here, but we have nothing to compare it to. So that is why it's a very bad design overall. So we can get better, make better inferences if we include a pretest. So even if we only have one group of people, but we have their scores on the same sort of thing before a manipulation happened, that would give us something to compare the post-test scores to. So here is another example where, say, this is kind of back in terms of there's some sort of a training program to help people stop smoking. And if we only, like the previous design, we didn't have this. So we only had like the training program and then smoking measure after the intervention. But now if we do have a pretest here, so the pretest is what makes this design different from what we saw on the previous slide. So now we can see that if within this single group of people, if they are actually smoking less as a result of this training program than they did before they went through a training program. So it's kind of similar to what we were just talking about in terms of the single case research designs, but the main difference here is that now we're sort of looking at it in terms of a group of people, and we're not looking at like each person individually. We're just seeing, like, does the mean number of cigarettes decrease at the post-test that people are smoking per week, let's say, than the mean number at the pre-test. So even though that, like I said, kind of that one group design is better if you have a pre-test as compared to only a post-test, there are still some serious sort of problems with one group designs that affect their internal validity. We're talking about 5 of these threats on this slide. So a history effect is basically sort of like any sort of thing that happened to people outside of the intervention that could be responsible for the results that we see. So in the case of like a smoking treatment or intervention, it could just be that like people were, like, a bunch of participants watched some movie that reminded them of how smoking is bad for you. And so that was what sort of caused the reduction in smoking at the post-test. And it wasn't actually the treatment that the researchers designed. So history effects is basically just anything that's happening outside of the actual treatment that could cause some sort of a difference in the outcome. A maturation effect is similar to a history effect, but it's more so like sort of the results of like changes within within a person that kind of happen more so like naturally with age. And so if you had like, say you had a really like a long-term study where you're seeing how this this smoking app like works over a sort of a year period, and the results seem like it does work, but like this maturation effect could also be responsible, and that kind of like as people get older, sort of naturally they sort of get more concerned with their health. And so could be that the smoking app doesn't really work, but people are kind of, they're getting older throughout the study also, and they're getting more concerned about their health, and that's what's driving their reduction in smoking. There's also sometimes there are testing effects where if you have a pre-test and a post-test design, just taking the pre-test can sort of change people's behavior. So maybe having to like report and monitor the number of cigarettes that you have each day, like that alone is sort of an intervention, and people maybe don't really think about it that much. And so they might like smoke less just because like they're shocked at once they actually start counting how many cigarettes they're smoking a day. So it would be like the act of testing that's driving changes, again, not the intervention itself. Instrument decay, that could be something where like basically there's some sort of problem with measurement that's responsible for results. So instrument decay kind of would imply that there's some sort of like a physical instrument that stops sort of working over time, but it could just be like more broadly, like there's just like, if you're still in the example of people smoking, maybe at the beginning of the study, they're paying a lot of attention to how many cigarettes they smoke per day. The more they do it, they just sort of get lazy and are sick of tracking all of them. And so they sort of report fewer cigarettes than they're actually smoking. And so again, it would look like there's the intervention is working, but what's really happening is there's just sort of a measurement problem, and that the measure is worse and missing out on like cigarettes later in the study. And then finally, regression toward the mean. So this is actually a really sort of interesting phenomenon that happens, and it applies to a ton of different settings. And it's often sort of a thing where in medicine too, like this is sort of a problem where like people sort of, they're most likely to go seek treatment for something when like their symptoms are at like the most extreme. And so you can think about it with like depression or anxiety, or you can think about it with like a physical problem. I mean, depression and anxiety are physical in some sense too, but so think about it like in general, sort of people are most likely to really like finally go see a therapist right when their symptoms are the worst. And then sort of what naturally happens over time is that if your symptoms are the worst they've ever been and you go see a therapist, like they're probably like, regardless of whether or not you saw that therapist, they're probably going to sort of regress back towards the mean of your like normal symptoms. And so the therapist might help also, but like this regression towards the mean is also maybe more so what's driving the effects. So it's the same, like I said, it sometimes it comes up with surgeries too, where like people they have some sort of a back problem and it's really bothering them, and then they go get surgery, but like they maybe wouldn't have needed that surgery because if they had just waited a little bit, it would have gotten better sort of on its own. So it's an interesting phenomenon that happens. And really the core conclusion from this slide is just that like these are all problems that we could control for if we had a control group. But again, in this sort of quasi experimental design, we don't have that. Or we don't have a truly random control group at a minimum. We are going to talk about next sort of some non-equivalent control groups. But if we had another group of people that we could compare that had everything else the same, so all these threats would still affect them, but they don't have the intervention. So like then we truly would know if it's just the intervention that's driving any changes over time, and not one of these other sort of effects that happens. So maybe we can't get a true control group that we got through random assignment, but we could still sort of try to get some sort of group of people that it's not perfectly equivalent, but it's similar in some sort of way. So in a non-equivalent control group design, it could be the case that like we have this training program, again, like designed to help people quit smoking. And we basically, like anyone who signed up for the training program, we put in the treatment group, and then we find like another group of people who, let's say that they are smokers still, but they didn't sign up for the treatment, but we still kind of want to compare the smoking, at least after a training program, in terms of people who went through it versus those who didn't. But so one really big problem with this design is that if you, without using random assignment, like these selection differences in terms of like the people in this group chose to be in this group. And so there's probably something like they maybe were much more motivated to quit smoking than the people who didn't choose to be in it. And so they're not equivalent groups. And it could be the case that like, it's not the training program, it's just the fact that they just wanted to quit a lot. And that's what led to a reduction in smoking rates. Or maybe these people just smoked less to begin with. And because we don't have a pretest in here, we have no way of detecting it. So this, if you only have a post-test, and so this is just called the non-equivalent control group design, and it only has a post-test, it's also what would be considered like a very bad design. We can do a little bit better if we add a pre-test. So a non-equivalent control group pre-test, post-test design is the same as what we just talked about, but now we at least have a pre-test for both groups of people. I know a lot of these terms are, they're just a lot of words in them, and I wish there was a way to describe it better with fewer words, but this is kind of the best that they can do, I suppose. So same sort of idea, where we have a non-equivalent control group. So there might be some sort of difference between the groups if it was, again, some sort of a smoking app in terms of like maybe the people who really sought out treatment smoked less to begin with. But now if we have a pre-test, we can actually see that. So we can compare the mean number of cigarettes smoked in the treatment group versus the non-treatment group, and we can see how big the selection effects were, and then we can kind of see that, okay, it's fine if people smoke fewer cigarettes here, but does this treatment still like lead to a similar like reduction in cigarettes based on the fact that they had started smoking with fewer, as compared to the no treatment control group design of people who didn't sign up for the treatment. So we're getting essentially, yeah, this is better overall of a design. So something that we can do that would be even better than that would be to in terms of getting that control group. So again, in these set of sort of hypothetical examples, we, for some reason or another, we can't get like a true control group through random assignment. But sometimes what you can do is get like, get close to a truly equivalent group by using this propensity score matching techniques. And so you can think about like a propensity score would be like someone's likelihood or the number of cigarettes they smoke per week. So that is like, it's everything that we know about a person in terms of what would create their likelihood for smoking a particular number of cigarettes per week. So if we have a treatment group of people who signed up for this smoking reduction app and we want to compare them to someone what we could do is kind of like create this control group of people, and for each participant in our treatment group, we want to have sort of like a matching person with a similar propensity score to smoke cigarettes in the non-equivalent control group. So we could, let's say, like we create these propensity scores by matching people to be like in the control group of similar age, weight, family income, and smoking levels, as compared to the people in the treatment group that, again, were self-selected into it. So the core sort of advantage of this propensity score matching is that it's going to sort of mitigate or reduce the disadvantages of studying like two non-equivalent groups, because we're getting closer and closer to sort of having a truly equivalent control group. So two final types of designs more, and then we'll take a break. So these are still quasi-experimental designs, but so interrupted time series design and then a control series design. So an interrupted time series design, the only thing that sort of makes it different is that now we're focusing on like a longer period of time before some sort of an independent variable is introduced. And also after. So think about like interrupted time series, like there's a long time series that's interrupted by the introduction of the independent variable, but that's what makes this design unique is the long sort of time series. So it is better, generally speaking, if we have a longer period of time, but it's the same problem with many designs in that there's, in this case, like if you only have one group or one sort of set of things that you're looking at over time and nothing to compare it to, you have all those sort of threats to internal validity that we talked about already. So just to kind of to give an example of when you might do an interrupted time series design, this is an example that the book talks about, where basically in Connecticut, in 1955, there was, it was like a really bad year for fatalities, like driving fatalities. So you can see like 325 people died in Connecticut that year. And so the state of Connecticut introduced this sort of like a series of interventions that were trying to reduce fatalities. And if you were just looking at, let's say, so just comparing 1955 to 1956, you would think like, oh, for sure, this is really working well. But what could be happening here is just sort of like a regression to the mean sort of thing. And that if we look, so we can see from 1951 to 1955, like 1955 just happened to be a really bad year, and it could have just been like sort of a coincidence. Like there's always sort of random fluctuation across the mean. And then this is what I was talking about with regression to the mean, is that oftentimes like people are most likely to do some sort of a treatment when things are at their worst. And when things are at their worst, even if there is no like external intervention, they probably are going to get better because things tend to regress towards the mean score over time. And so in this case, like, yeah, there were fewer fatalities the next year, but there were still more than there were in like the previous years. But because it's an interrupted time series design, like we're looking at it over more than just the 2 years, and we can sort of see that there's a downward trend. And so I don't know, there's a little bit better evidence that after this intervention was introduced, like that it did have some sort of effect. But in this case, like the big limitation sort of here is that we only have one state that we're looking at. And so there's no sort of control group, and there could just be a ton of other things that are happening in Connecticut that are causing a reduction in fatality rates. So the final design that we're going to cover here before the break would be a control series design. So it's the same as what we just talked about, but now we're introducing like a comparison group or multiple comparison groups. We're still looking at something across time, but in these sort of comparison groups, there was no intervention. So to do so, it's still sort of a quasi-experimental design. We didn't get these control groups through like random assignment. So we have to kind of go out and find some sort of a similar population that didn't receive the manipulation. So in this case of traffic fatalities, like what you could do is just compare Connecticut to other states. And so that's what they did here, where this dotted line is the fatality rate in 4 comparable states to Connecticut. So like 4 other East Coast states. And this is just the average fatalities in those states. What we can see is that like it's pretty stable across these states. So there was kind of a very slight reduction over these 9 years, but it does seem like, I guess, a little bit better evidence anyway, that in terms of just comparing it to Connecticut, like that after this intervention was introduced right around here, that the traffic fatality rates in these other states kind of remained fairly stable. Again, a slight decrease, but it wasn't as big of a decrease as there was in Connecticut. So this would be stronger evidence that this program did have some sort of effect. So I know that's kind of a lot of different designs that we just talked about. I think for the most part, even though they have long names, the names just try to like use the names to remember what they are, because the names are fairly descriptive of what they are. And again, all of these designs were sort of similar in that we don't have a true control group that we got through random assignment. So we're kind of having to do the best we can otherwise. And then I guess the final thing I'll say just as a summary is that all the sort of one group designs are pretty bad overall. So especially one group designs without a pretest. So having a pretest is super important in order to see that any sort of effects were truly real. With that, let's take a break. We have fewer things to cover after the break, so we will get through, I think, this whole chapter with plenty of time. So we can take a break till, let's take 6 minutes. So you have till 11 o'clock, and then we'll finish up the rest of the chapter.
Dr. Hoff, I just want to let you know that I emailed you.
Okay, I'll check my email. So I'll see that. All right, so if everyone could come back to the screen, we can finish up the chapter here. So basically there are 5 slides left, and then a review, and all 5 slides are focused on essentially like developmental psychology sort of questions. So developmental research designs, I guess, as this title says, where basically sort of, the main focus of developmental psychologists is to study how people change as they age. And there's 3 sort of general methods of doing that. So the cross-sectional method, we've seen this sort of term before, but it's basically just like you only have one survey measure or one measure of whatever you're studying. But you have people like of different ages who can be compared at that same time point. So you could compare people's like any sort of variable you want and how that differs across age. For the longitudinal method, so it's longitudinal, which basically just means like you're following people across time. So here you can study the effects of aging within one group of people as they grow older. So you have multiple measures of those people throughout time. Generally speaking, the longitudinal method is better than the cross-sectional method. I'll explain why in the next few slides. And then finally, the sequential method, which is basically just like kind of a combination of these two, where you would follow people longitudinally, but you'd have multiple sets of people that you're following longitudinally. And so those people, at least at the first time point, like differed in how old they were. So you can compare people of different age, like within a single time point, and then you can compare how these people of different ages are changing in terms of as they get older. So the sequential method is kind of generally speaking even better than the longitudinal method because it combines both longitudinal and cross-sectional. So just to kind of illustrate a little bit more what I'm talking about here, in terms of just comparing the cross-sectional versus longitudinal design. For cross-sectional, we just have one measure basically at a time, but we have people of different ages signified here by the different colors. And so we can compare them to each other. Whereas in longitudinal design, we have one group of people and we can compare each group to themselves basically at different time points. So seeing the effects of aging more directly. So just to kind of talk about why, when I said the longitudinal design is better, to explain why. I guess one thing to say is that the cross-sectional method is cheaper. So in that sense, it has advantages, but there are problems with it. So the reason cross-sectional method is cheaper is that you only have to do one survey of people. And so it's easy to do that, generally speaking. And you can compare people of different ages like really immediately. So you could get your data and the next day you could be looking at any sort of age differences. However, the biggest problem with this design is that you can't know definitively whether or not, if you do find age differences in a particular variable, that those are actually due to like the effects of aging, or if they're due to what are called cohort effects. So a cohort is basically like a group of people that were born at about the same time and thus were like exposed to the same sort of events in society. And so cohort effects are basically just, any sort of differences among age groups that are not the result of aging, but are instead the result of some like social, cultural, economic, or political differences. So like in terms of a big cohort effect would be anyone who sort of lived through World War II. And so that affected people in a lot of different ways. And if you lived through that, then that was like, you know, a huge sort of source of how you became the person you are, or had some sort of big effects on you. That if you're comparing people who grew up during that time when they're 80 to like 50-year-olds who were too young to have experienced anything through World War II, then like any differences that you find between 80-year-olds and 50-year-olds could be due to the fact that, again, they're 30 years older and the aging process like caused differences, or it could just be due to yeah, this sort of shared experiences of World War II shaping them when they were younger. Maybe another maybe better example would be like technology. So there are many books written today that are basically sort of saying that these younger generations are like more narcissistic because of technology. And there's also kind of research that says that it's not true, but one sort of big problem. So if you compare people's narcissism levels at different ages, they tend to be, so people get less narcissistic as they age. And so that sort of finding you can only get from a longitudinal study, that like the same group of people, if you measure their narcissism levels will go down across time. But if you only have the cross-sectional method and you're comparing like 40-year-olds versus 20-year-olds in terms of their narcissism levels, you would see that 20-year-olds have higher narcissism levels. And so what a lot of sort of authors have done is sort of claim that, oh, it's the me generation or whatever, that it's all this technology that's causing this particular generation to be so narcissistic. And what they're doing basically, they're confusing, they're claiming that there's some sort of a cohort effect when it's really just sort of an aging effect. So that's why the cross-sectional method, it can't essentially tell apart the effects of aging versus cohort effects. With the longitudinal design, yeah, so it's needed basically to conclusively know if any sort of changes in people as they age are truly the result of aging. So the simple sort of thing here is just that, yeah, we're following the same group of people across time. And it controls for cohort effects because you're following the same group of people who all were in the same cohort. And even if you could sort of study people at different ages at the first time point, but again, like they're still in the same cohort that they started with. So cohort effects are not what would be driving any sort of changes across time in a longitudinal method. The big downside is that it's expensive and sort of time consuming. It's always a challenge. I actually do a lot of longitudinal research myself, and it's hard to get people, it's hard to find people after they've like participated in a research study. And then if you want to have them take a survey like a year later, you're going to lose like half the people sort of automatically, just because people don't check their email. People, maybe they see it, but they're like, I don't want to take that study again. So you lose a lot of people across time, and you have to really like incentivize them to come back. So like the research that I do, we pay people like $20 to take a survey. It doesn't take very long, but just because we need them to come back and complete the survey later on. And then the other big downside is that like you actually have to, if you want to see the effects of aging across a 20-year period, you have to wait 20 years. And so that poses serious limitations to a lot of people's careers. And if I'm a researcher and I have to kind of publish to get tenure, or I just want to know something and I don't want to wait 20 years, then this design is not really going to help me much, unless I go find, what a lot of people do is they find longitudinal data sets that are kind of older, but have already been completed. And so then you can use those to study the effects of aging over a longer period of time. So finally, the sequential method was the third sort of method that we're talking about. And the big advantage of it is that it's essentially like, again, it's combining the cross-sectional and longitudinal designs. So you could just think about it like this sort of diagram that you have here. We would have two versions of it, and they would be of people from different cohorts. So we can compare basically at a single time point, we can compare people of different ages, which would be the same sort of thing that you do in a cross-sectional design. And then we can also see how these groups change as they get older. So if that's not clear, hopefully this diagram will make it clear, but let's just go through it sort of step by step here. So just focusing on this box here that says cross-sectional method. Say I want to compare people's narcissism levels depending on and how that differs across age. And so if I just have the cross-sectional method, I could compare 55-year-olds to 65-year-olds at one point in time in 2010. And maybe I find differences, but it could be the fact of like either aging or it could be when they were born. And so again, with the cross-sectional method, I have no way of knowing definitively. With the longitudinal method, I could just focus on one of these cohorts and I could see like as this cohort gets older, do their narcissism levels decrease from age 55 to 65. And here I'm controlling for cohort effects because everyone is born in the same cohort when they started the study. So if there are differences, I would know pretty definitively that it was the results of sort of aging or maturation that was causing it. And then the sequential method is, again, it's combining these two. So it's basically just like we have two sort of sets of longitudinal studies where we follow one cohort. So it's the same thing as this across time. But then I also will add another cohort of people born in 1945. So now I can, even after the first time point, before any sort of longitudinal data is collected, I'll still be able to compare 65-year-olds to 55-year-olds. So I get some data right away. And then I can also compare these groups to each other as they age. And so one other thing to note is just like that the full sort of age range here. So starting with 55-year-olds and 65-year-olds in two cohorts, these 65-year-olds are going to get 10 years older. So now I have like a 20 sort of total year period of effects that I can see. Of course, these 65-year-olds at time 3 are not directly comparable to these 65-year-olds because of cohort effects, but still sort of like a broader age range that I can get at right away. So that is it. Again, just to review, sort of these single case experimental designs are not great, but you can, if you only have one person or if you only have like 3 people, you can use sort of changes within that person to study sort of causes and effect. And you can do different things where you like introduce an intervention and then take it away. And that's, it's called a reversal design. If you have enough people to have like a group, so that would be like at least sort of 10 people. The one group post-test only design is a terrible design, generally speaking, because you only have one measure and you have nothing to compare it to. The one group pre-test, post-test design is better because now you can compare the post-test scores to the pre-test scores and see if the intervention had an effect. But that sort of one group design is vulnerable to a lot of threats to internal validity that just have to do with sort of like how people change across time generally, or the effects of testing or regression to the mean. And so having a control group helps you rule out a bunch of these potential threats. And so even if you can't get a truly sort of random equivalent control group, you can still do your best to get non-equivalent groups that are similar. And then what we just talked about are the 3 different methods to study development across time. So that's all. Now let's put this beginning slide up here one more time, just so it was a reminder of what's due this week. So make sure you don't forget to do quiz 5 in addition to the SmartBook chapter for this week. And we are winding down, so almost to the end of the semester, and keep up the good work, everyone. And have a good week.
Thank you.